Hi, I'm going to do a short demo to show how information disclosure at the shell level enabled me to run an exploit during one of the assignments. So you can see here, I set up an environment variable, binsh, and sent a string to it. Just check to see if that was there. It looks good. And so if I go in and look at assignment 3 now, quick look at the source code that was underneath that. Remember, there was an str copy function. So I'm going to want to set a breakpoint after that copy function. This buff variable is the one we will overflow. So I'll set up that breakpoint, and then I can run the program. It's expecting a string of characters. So that gives me this view. I can see the storage for the buff variable is going to be at hex 14 offset. So I can take a look at that. So I go to EBP hex 14. Okay, and that shows me the address at which that variable is stored. So I can do a quick check on that to make sure I've got what I need, and I do have the input string that I added the command line argument. Okay, so next I want to check the return code from that function. So I see the function strcopy is called from here. So control should be returned to main at this address, 080484D0. And I want to see where that return address is stored because I want to overwrite it. So I can take a look at, let's go to EP. So I want to take a look at that, where the return address are stored. And down here I see it. I see the 080484D0, little endian style. And so the address at which the return address for that str copy function is stored is at this memory location here, BFFF0BC. So now I want to see what the offset is between those two addresses. So if I take the address here and subtract the address where the buff variable started, I see that I've got a hex 18, so 24 bytes between those two addresses. So I need to keep that in mind. Now I can find where the environment variable is stored. So I want to find that bin sh asset. And I see here it's a BFFFD25, and it's got the string I intend to. So that's good. I will need to be able to point to that when I make a system call to run the shell. And to make that system call, then I need to find out where the system function is stored in memory. And so the libc system function is stored here at B7E50310. So all of this information allows me to set up the exploit. So what I want to do is I want to overwrite the return address from the str copy function with this address. So I want to run the libc system process, and I want to pass in as an argument this address, so it'll read the command bin shell and open up a shell for me. So I thought I was all set with that, and I'm just going to grab the exploit I ran from here, because you don't want to suffer through my typing. So quit from here. So back in my command line, I can write this command to run the exploit. So I'm calling the program with the vulnerability, assignment 3, passing in as an argument. I'm building this string with Perl. So I saw 24 bytes of offset, so I'm just going to print the character A 24 times. So it's going to be from the start of the buff variable. I know I can overflow it, and I want to overflow it up to where I want to put the return address or overwrite the return address with the address of the system function. So remember, the system function, when we found it, was stored at B7E50310 from here. Then after that on the stack, it's going to store the next address, the return address from there. So I just overwrite that with any data. I don't care. I'm going to work in the shell, so I don't care where it goes after I return. And then finally, here's the address for the environment variable I set up. So I want this to go as an argument to the system function. So it's BFFF FD25. So when I tried to run this, I thought it was all set, but I see I really didn't get a shell. However, the shell did give me some information that it really shouldn't give me. So I see here that when I run this command, I got back some text, and what it's doing is because the environment variable storage is offset between sort of debugging count and my execution count, I'm not quite getting the right address here. But what this information disclosure exposes to me is I have the right run for the system. I'm calling to the right location to run the system function, and I've overwritten the return address correctly. And I know that because the shell is responding to me. It would be better for security purposes if this shell did not respond. But now it's confirmed to me that I'm in the right area, and I know that all I need to do, and the right area of code that is, or memory location to find the environment variable. So now all I need to do is iterate through this, and it'll be a fairly small region. It's going to be a fairly small region of memory, so it's not a large brute force effort. So I iterated just through the last 2 bytes of this in a short script that I had called run exploit. Just a small shell script that basically ran this command and just iterated through the lower 2 bytes here. And so when I do that, I see it runs the first time with this variable. I started at 3B, counted my way up, I got 3C. Eventually, I hit the point here at 3D for that location in memory for the environment variable, and voila, it worked. Got myself a shell. And so I can run shell commands from here. I can even go change this user's password if I choose, and then I have got their password and username, so I didn't change it here, but I could change it and could go into any other application that they run on this system legitimately now with their password and username. So point here, the exit from this, by the way, I'll see my loop continuing, but I don't care about where it continues. I just know that I got the shell that I want. So the information disclosure here from the shell actually responding to me really made it much easier for me and confirmed to me that I could actually run the system command and then could just loop through to find a meaningful command to run. Of course, I can change that environment variable now to not just the shell, but to actually run commands like an ID, password change, whatever I want to do from there. Now that I know I've got that parameterized value essentially in an environment variable. So that's the danger of information disclosure at the shell level, and why we need to protect it and think about protecting the stack from those kind of threats too. Thank you.